This is 5-31. This one we got a steel shaft, has a diameter of 25 millimeters, supported at D and E. The motor produces 3 kilowatts of power here. The shaft is turning at 50 revolutions per second. If gears A and B are 1 kilowatt and 2 kilowatt respectively, determine the maximum shear stress developed in the shaft within regions of AB and BC. The shaft is free to turn in sport variants. Okay, a couple things to note on this one would be that from here to all the way over to here, you only have to be worried about 1 kilowatt. Now when you get into this part of the shaft, it'd be 1 plus 2, which equals 3, or you can just base it on the 3. So in this area here, it's going to be 3 kilowatts. And then within this region here, you just need to be worried about 1 kilowatt. Okay, things to note is that 1 watt is going to equal to 1 newton times meters over seconds. The equation for power is going to equal to torque times omega, which is our angular velocity. Here we got 50 revolutions per second, so we need to convert that to radians per second. Let's do that real quick. We'll apply that by 2 pi radians. And 1 radians, 2 pi radians, 1 revolution. We go ahead and do that multiplication. And then we will get the angular velocity in radians per second. And we can just call that 100 pi. Okay, so let's find out what the torque is going to be between A and B right here. Then the torque is going to equal to power over omega, which means we'll give it to power, and we had 1 kilowatt, so we'll make that 1 times 10 to the 3rd watts. We'll divide that over 100 pi. And that'll give me a torque of 3.183 newtons times meters. Again, that's a torque between A and B. To find the torque, let's do the torque between BC. We get our power output between here, which is 3 kilowatts. So let's use 3 times 10 to the 3rd watts over angular velocity 100 pi. That gives us a value of 9.549 newtons times meters. We'll scroll down and then again just go back to your basic equation where shear is going to equal to T times R over J. If we want max, then we go all the way out to the far radius. So the torque, the shear at AB max would equal to the torque times the maximum radius of the shaft, and we have a 25 millimeter diameter, so we need to convert that. That would give me 0.0125 as the radius, and then all we have to do is divide by the polar moment inertia. It's a solid shaft, so it'd be pi over 2 times this radius to the 4th power. And that gives us 1.04 megapascals. We do the same thing for BC. And the torque was 9.549. We'll apply that by the maximum radius. and divided by the polar moment inertia, which again is pi over 2, 0.0125 to the fourth power, gives 3.11 megapascals. So this is a pretty easy problem. Okay. Best of luck on future problems.